Hello, this is Richard Leeson. And in the previous section, we talked about the calibration of the model from our site meters, and we talked about how we were going to create our first alternative. And in the alternative section, so you can see what we have here, we've got our energy study, and where we on the study information page is where we actually add our alternatives. And so we would actually hit this create alternative button here to start that process. But what I wanted to do was take a quick aside here and talk about kind of what we're trying to do and what we're trying to accomplish with this. And so I first wanted to kind of go over these definitions, and some of these we've gone over before. And I just, like I said, just want to go over those again. So our framing goals, which are very important because that's what kind of is driving what we're trying to accomplish, what detail level, who our parties are that are involved in this. Is it energy? Is it sustainability? Is it source, carbon, greenhouse gas, whatever's driving this study? We want to put and record that information so as we are going through this, we can incorporate that into our planning decision. We just looked at the baseline, and the baseline is a snapshot of the current energy use situation of the study area. We can always get a snapshot of our meters, whatever that is at installation, but we're trying to get that snapshot for what we're trying to focus in on. And then, so what is this first case we're trying to do? Well, we call it the base case, and it's the baseline extended to include already funded features, or basically a look in the future at a future reference point. And typically what we do is we look at what we want to do for the next 40 or 50 years, whatever that planning time frame is. We want to do that with the projects as we currently have them, as we would have done them if we had done nothing else, or in other words, business as usual. And then after that, that's our true comparative case. So what's our future case look like, doing everything as we would have done it anyway. So then we also want to look at a set of those comparisons against that with other alternatives, be it better, best, others could be renewable, however we want to set that up, as we go forward. Site energy, of course, is what's measured at the site. The source energy is measured at the generation of the source, be that at the power plant, if you want to take it all the way back there. And then we did talk about that district and cluster level, or we call it the installation level, where we put together groups of buildings to be served by a combination of supply factors, be it retail, gas and electric, to stuff that we actually produce on site. So we're going to be looking at that next case, which is this base case. Like I said, that's our snapshot going forward. And at this time, I also wanted to talk about kind of the process overall again, just to remind us where we're at. So in our net zero planner process, we establish our planning goals, and those are the framing goals. We just talked about that. We establish our baseline and base case. And then as we go forward, what we're going to be looking at, and we're going to see how the tool kind of embodies this process in it. We're going to optimize our energy efficiency, and we're going to do that what I call a smart energy expert, how they would probably go through that. 9 times out of 10 they would follow this path through the building. We want to take those loads and then pass it to the installation section, which we saw last week as we passed the baseline loads, and we want to look at options on how to do that. And then we want to put together our plan for our 30 or 40 for our planning study length, and how we want to execute that, and in our decision and planning process. And of course, what makes this nice is that we can loop back through this as many times as we need to update it as we go. But what do we look at when we get into each of our individual buildings, and this is kind of the process that we follow as we're trying to do this. And so this is kind of a theoretical depiction of an ideal path of where we would want to go through this process. And so let's just go through this quickly, so we have an idea of what's driving us in this direction. So we start out here at point 1, which is our business as usual. It's what we build to as our standards, our requirements, and this total cash on this side. This is kind of the dollars to build the building in dollars to think of it as your mortgage, if you think about it for your house, and then your utility bills built into one. And then as we go from here on as we reduce our fossil fuel, or we produce more and more on site, or become more energy efficient, we want to get to 100%, is that we reduce all we produce all the reduction here. Initially though, we follow this path down from 1 to 2, and these would be energy efficiency measures where the energy reduction is greater than the cost to implement it. So we'll see an overall reduction going down here from 1 to 2. So lighting projects where the cost to implement the lights increases the mortgage sum, as you can see, but then you also get the savings. You get a larger savings in energy to make up that difference. You eventually get to a point where that levels out, and that's kind of this point 2, and this would be an area where most people try to drive all their projects, is where we're getting this life cycle cost, which is the lowest, and this is all done by where the delta the energy cost is greater than the investment. But eventually we get to the point where we're starting to get where the energy savings isn't as great as the investment. But it's still a good thing to do if our goals are beyond this point 2. As we keep investing in the building with technologies, we eventually get back to where we now have a larger investment piece here, but our building is our combination between the investment in the building and the energy bill is now on par with where we started, but the building's a lot more efficient, and our utility side of this is a lot smaller than where it started out. And if our goal is to get to this point, and this is somewhere in this neighborhood in here, a lot of times is where we come up with the best, where we kind of cause the best category. So we go beyond the no-brainers, as I kind of call this point up here, and then we go beyond that and we invest more in our building, where this package, if we put this all together as one, would be better than where we started out. So this is kind of where that best range lies in. And then if our goal is to get to net zero or 100% fossil fuel reduction, or some type of energy security goal, then we would have to push beyond that. And we keep pushing where it makes more sense to still invest in the building. The returns are better there than if we had to generate our own supply and our own energy security, our own storage. And there's at some point, this point 4, there's this theoretical point where it's more cost effective to invest into energy supply than it is into the building itself, with further reductions, further technology increases. So this is a theoretical point out here, point 4, where we would stop investing in the building. And I think of this, and if you go back to in terms of your residence, this would be the point where it's cheaper to add PV to your home than it would be to continue to work on reducing the energy consumption. Or the avoided, I call this investment here is kind of the avoided cost of supply, or in that case, the avoided cost of PV. So you would still do things that it would be less expensive to do that than it would be to generate your own. Like I said, this is all dependent on your goal, what you're trying to accomplish with your installation, and where you're trying to go with this. So that's why that framing goals is so important, and then you have all the people involved who want to make that decision, so we can set those. But with the Net Zero Planner, with this tool, we can investigate those points, even if we just to see what it would take to get there, how much the cost would be to get there, even if we may not necessarily choose that as our option. So it's great to investigate endpoints, and as we go forward. So, but as we look at this, we can see a lot of times that when we put up our best alternatives, we're going to end up in somewhere in this neighborhood on the right-hand side of 3. So we're pushing all of our technologies and trying to push our limits, trying to get us closer to this point 4, where we're then going on to the installation section to look at the rest of this. So what we want to look at here is just kind of this overall look at how we want to produce this curve and what we're looking at as we're walking through this path. And that's in this path is different from a new building to retrofitting an existing building, and you'll notice that the energy efficiency measures are set up that way, so we can see that in there as well. And then lastly, we'll just review the process. So we gather the information, we select all those baseline packages and EEM packages. So we simulate all that. We run that through once again those curves. We want to find the best cost energy curves and SIR for all those packages. We select all those. We then take all those results as we select those in the package selection piece, which is here, and then we in the site summary reports we see that all that rolled up data, so we can see things which would have office buildings which would have high daytime loads, sleeping residences which would have evening and nighttime loads, and then other things that are just driven constant or kind of flat day and night. We add those all together and we pass that to the installation section. So what we're seeing here is kind of the building process, what we're going to try to accomplish with these pieces. So we start that process here by clicking on our alternative. We're going to label that the base case, and we click OK. Now the important thing here is to make sure that we're done with our baseline. So all those changes then roll forward, and we grab all those changes. And those changes, we grab all those changes across the entire thing. So we grab all the facility changes in that alternative, and we grab installation, and all that stuff then gets rolled forward into this base case. So we just continue. We've already gone through these steps, so we're going to go to the facility, to the inputs, and look at our EEMs at this point to see where we're at in this process. So still energy, but now we'll look at the baseline. We'll notice that when we pull this back up, that nothing's really changed here, and we'll see that in a minute as it loads that. And this has all been saved. That's what these green dots tell us. So this has all been saved, and all this has been captured. But now we move to the base case, and like I said, the base case looks a lot different than this baseline. And as you notice here, that it's not been saved. This is the first time through we see this. It's not been saved. But what we'll look at in all these models is we'll see kind of this path. So for an existing pre-1980, we're going to see this set of packages, which is going to be for this brigade headquarters, which is going to be lighting, equipment, infiltration, HVAC packages. We're going to change. We look at changing the chillers. We look at better pumps, better controls, reducing duct leakage onto cool roof, daylighting controls in this case. As we get further and further into what we can do to this thing, we can look at envelope changes, kind of as the last thing we were able to do on a retrofit. And we're going to talk more about this one as we look at the better and best. We are just trying to generate the base case, and so we want to make sure that our baseline captures our base case. And then if we've done some of these things, we want to make sure that has also been changed in our packages. So if we've already done things, we've increased the lighting some, but not all the way. But most of that we're going to assume is we've captured that in our baseline. When we look at this list of buildings here, we see that now in our alternative that we have the existing buildings in our planned buildings, our demolished buildings have been removed from this list, and we look at our existing and our planned buildings. So let's open up this general instruction building, which has an existing pre-1980 set of packages on it, and compare that to our general instruction building planned ASHRAE. And so one of the first things you'll see here is this goes kind of like I said from the high impact EEMs, infiltration lights, equipment, all the way down equipment to in an envelope. And you go from there, you'll see that it's on a planned building. It goes from envelope, infiltration, lighting, equipment, and then of course what we have here is the ability to evaluate other HVAC replacement technologies that we can apply to this building to improve it further, because we're going to start out with something that is very efficient, probably the VAV, and as we can look at that. But one of the things that we have here that we don't have for the other buildings is we see our default packages here. So this sets all of the baseline parameters as well, because this is the first time we have viewed this information, and it's all available here. So we have all the things that we saw in our baseline for their existing and demolished as our first package here. So we see that here, and so we can see we started with the VAV, which is very efficient. We're starting here with 11 R11 as our wall insulation on a continuous wall, and then we got our 20. And let's move on and see what the package looks like. So the package is going to have cavity of 19 and R30 in the wall as an option as we get better, and then we're also going to see 50 R50 instead of R20 to see what that would look like. And then we also go to a better windows in this as well. And then in this envelope package, we're going to go to our cool roof parameters. We'll tighten our building up further, possibly look at adding a vestibule on our entrance to make it even better. And then we can see we go to our lighting parameters, which are better than what we started out here if we looked at our lighting parameters in this case. So we see our densities have decreased as we get better lighting packages put in place. So you can see we probably still want to do all those high impact things in our building, but we want to make sure that we start out with a good base building as we do this. So that's kind of the idea of how that path goes for planned versus our existing, and we look at the incremental costs on these things, and we see, those get implemented. They're at slightly different cost structure than they would be for retrofit on all of those. So in this case, we're doing the base case, and like I said, we're going to try to capture most of that stuff in our default package. So we do have to look at our plan buildings. We have to look at those defaults and make sure that they're good for our building. And so we have those at in all of our plan buildings. We have all those things in here. Here we have our warehouses, so we have to check those quickly to make sure that they line up with our what our buildings currently look like, what we're planning to do with our planned buildings, or kind of our business as usual for how this would be constructed. We'd want to check all those as well and line that up as well as we go forward. And once we've done that, there's another thing that we'll see here, and it's this install cost. And if we put all this in and we work all these packages through on our base case, and we see our install costs, which is our incremental cost for this package, not for the passive house and a cool roof, but that put together at $3 per square foot. This is our cost, and we're going to have another discussion on that as we look at our better and best case. We're going to talk much more about this install cost as well. But this is where we're going to actually generate the cost basis, or the delta cost basis, for what we're going to as we go forward. So kind of want to look at these things and just introduce them now, but most of the times as we go through and do this alternative case, what we end up doing is going through checking our plan buildings really quick. Obviously one of the big things is to save those changes and get all that saved in for this study. So anything that we've changed here will be saved as we go forward. And as it does that and reloads it, we'll see it's all turned green now, and then we can go forward into our simulation piece here. And as we open that up, this is why we really want to make sure that we have established a good baseline, because now as we make changes in our baseline in these 17 runs, if we want to go back and change that, we're going to be carrying this alternative set of runs or alternatives with us, which in this case added all those alternatives that you saw for each one of those different facilities. And so if you look at that, let's say there was 17 facility groups, you're going to add something on the order of 10 to 12 or so alternatives on that, and so you can see it goes up drastically. So we really want to make sure we got our baseline set, because redoing a few runs out of 17 compared to that multiplied by 10 to 12 for every change we want to make here, it's not that it can't be done, it just takes more computation time, and it just decreases our reaction, how quickly we can go through and make our changes, look at those, and come back to it. So we really want to make sure we do a good work on the baseline and have that done before we start adding alternatives. And that's true at the installation section as well. We want to make sure that we've carried it all the way through and we're really comfortable with that baseline. And I keep talking about that because I want to make sure that I've reiterated that several times, just to make to really get that point across. We really want to have a good baseline as we go forward, so that when we run this, things will go a lot smoother in the future. So at this point, we would hit that start the simulations, and we can see as it goes through those first 17 went quick because they've already been done, and then it goes through and it checks in the database to make sure that if there's one that's been identical to that one, it will pull those results back over, and then at that point it'll send anyone that hasn't been needs to be updated. It goes off and we'll send that out to the job server to run through, and if it it'll go through and look at those simulations and start pulling all that information back in. So this doesn't take that long, but we're not going to sit there and record this, and we'll come back when all these packages are done. Okay, then after about 10-15 minutes and everything is run, I just hit the refresh a minute or so ago, about 2 minutes ago. You can see everything is now turned dark green, which says it's successful, and we see that the package selection has lit up, that we know that we can actually move forward. So we go ahead and move forward, we select energy, and now we see this looks quite a bit different. Inside here, we'll see all of our runs that were made and in all the results. So just for an example, let's go back to that GIB existing that we looked at in the GIB planned, and let's go ahead and pull those results up. And what happens when you hit the little view button is it goes out and pulls all the results from all the different runs, and we can see what the baseline, in this case for the existing, it was the baseline, and from there we can see what the infiltration, we can see the reduction as it goes down here, and as we go, and I'm going to go ahead and pull up the planned one as well, and then we're going to go ahead and expand it out. So we can see all the results, and we can pop between these two. So for our existing general instruction building existing, we see this. We also see how that package install cost builds in. So we see that it's like $1 per square foot for infiltration tightening. We add about $2 a square foot. This is accrued, so this investment accrues as well. So we see the total enhancement cost accruing from $461,000, and this all depends on which facility this is and how much square footage is in it. We can see the electric usage, the electric cost, the gas cost, total utility cost. So we see the utility cost going down, pretty much, straight down from total utility cost of about $500,000 per year down to less than half of that, probably at 55. That's an energy reduction, not a cost reduction, but it's pretty close. We can see the enhancement cost increasing from $500,000 up to about $9 million, and we can see the annualized cost here. And this is where we should kind of see that curve. And so we see that initially we see our high value options bringing us down, and then we invest larger amounts, like in the HVAC package. We see that it comes up a little bit. The daylighting controls are good. The equipment package adds overall value, and we can see here, even when we get back to the all the way through with the envelope and the cool roof, we don't get back to our initial baseline cost. So this is a good set of runs, and from here we can decide, if we were looking at better and best, we would decide what alternatives we would look at. Now in the planned, we can see the envelope, infiltration, lighting, HVAC, and we can see these packages. But you got to remember, there's a lot better starting point on a planned building than there is on this pre-1980 building, so we don't get quite the bang for our buck. But all these packages are important, and we can talk about that at a later date. We still see the install cost accrues, the enhancement cost, the additional expense to build this more efficient building accrues as we go through, and then we look at that annualized cost here as well. Okay, and we're going to talk more about that package selection piece when we get into the better and best case. In our case, we're going to come up here, select the baseline, and then we're going to select the baseline, and we see that the default package was successfully selected, and you can see after we make that selection that now the results have actually lit up, and that allows us to go to the next section. And if we come in here and we look at this, what we see in here is, for an existing building, we see none of these were picked. That means that the baseline was. And if we go to a planned building, what we see is that the default package, or that first initial package. So what we're looking at is kind of that business as usual, without all those programmed improvements that we could make to the building. We go to the results section, and once again, I start out with the site summary. And we'll look at some of these other reports as we get further along, and we get more alternatives to look at. Some of these will make more sense. We do have these package parameter summary reports, which we'll look at as well. But we've gone from 53 facilities. We have demolished some. We've built more. We've gone from about 3.2 million square feet in our study area to 4.5 million square feet. So we've put together some fairly large building plan over the study life. And now we come over here and we look at some other interesting things at the rolled up level. So we see that our site electricity went up, and that's because we now have more buildings. As a matter of fact, it went up by a minus 37%. In other words, it increased by 37%. But our intensity went down, and that's because we got rid of older buildings that weren't as good, and we replaced them with newer buildings. So just that piece right there alone gave us a little bump. And the same thing with our site gas intensity. So this is what we see just by improving our building stock at business as usual. And we dropped from 120,000. This at a intensity level, we dropped from 120 kBTUs down to about 115. So we got about a 5 kBTU per foot squared on our building stock, even when we increased it. But we did increase. We added quite a few more buildings, and so overall we did consume more electricity, and it cost us more overall. And so this is where, as we look at our better and best case, we hope to be able to still have all these facilities, make the larger improvements to where we don't have to increase our energy cost. And if we're on a limited distribution, in other words, we have a limited electrical distribution or some other equipment limit capacities, sometimes there is additional benefits to improving the buildings beyond just what it can save just at the building level. But at this point, we've got the same facility group breakdown, except we don't have the demolished are gone and the planned are in here. And if there was since we picked the default, pretty much all these numbers will be the same from one to the other. Since we picked that default, we didn't really improve them, so to speak. So they were all pretty much look the same. So we'll see that when we go to the to our better and best alternatives as we go forward, we'll start seeing some of these differences and start looking at that in more depth. And at that point, we will find that a lot of these other reports will be more interesting to look at. So we'll look at that. We'll look at those as well at that point. So at this point, I think we're going to wrap up for this session, and next time we take up, we'll be looking at the installation section and carrying this base case through it.